All right, so now we're going to be talking about different applications that go with this. So the first one is going to be arc length. Now, this is a total shocker, not being sarcastic at all. I'm just straight up telling you. I'm going to actually give you these formulas, guys. What? I know, right? So we're going to be talking about several different formulas that we're going to be doing. Arc length, linear speed, angular speed, these kinds of things. So we're going to be working through those and working through some examples that go through those, but I'm going to give you the formulas. However, I will simply give you the formula. You have to know what all the variables mean and how to use it, right? So that's fair. Arc length is denoted by the variable s. I don't know why. I have no idea why, but it just is. So the variable s is typical in terms of arc length. And this is equal to r theta. Now the kicker whenever it comes to this arc length is that theta is always measured in radians. So that means in your calculator, you are going to have to shift the mode of your calculator into radians. So when we're talking about the degrees that are associated with this, or if you're given something in degree, you need to convert that to radians and work in terms of radians in your calculator. Okay? So S is arc length. R is, of course, radius. And then theta is your angle measurement. Angle in radians. That's an angle. Okay, so let's do it right now. The first problem that we have is example 7. We are told that a circle has a radius of 18.20 centimeters. We want to find the arc length of this angle. So that's circle. It looks like a D. That's a C and an L. The first one I have as 3 pi over 8 radians. Well, that is super sweet. I just want to find arc length. I didn't write that down. So find that arc length. Okay, plug it in. S is equal to r theta. I know my arc length here. My radius is given to me at 18.2 centimeters, and my radians is 3 pi over 8. Now, as we go through and we're working this out, we are going to round these to the nearest 100th position. And the reason why I'm rounding to the 100th position is because I have two significant figures right there, right? Two significant digits after the decimal. So then that's my tip off that I'm going to round to that also. Let me scoot this up. Literally just plug all that into your calculator. When you plug all that into your calculator, you should get 21.44 centimeters. All right? That's all we're doing. We're just plugging this into a calculator. What if, because you know this was coming, I am given 144 degrees. Ooh. Okay, so at 144 degrees, now when I go to plug this into my formula, S is equal to r theta, but I know theta has to be in radians. So I still have 18.2, but for my degrees of 144, I have to make that conversion, right? So my degree here, or my angle measurement, is going to be the conversion but from degrees to radians. So just put that in there as that conversion. Now you can convert it before, or you could just convert it at the time. I don't really care. You could do this as a separate thing and then plug it into your formula. It don't matter. This is all going to end up happening. So it's all multiplied together. Plug all of that into your calculator, and then you come up with 45.74 centimeters. The kicker to this formula, I was going to say equation, but the kicker to this formula is that you have to be putting your angle measurement in radians. If it gives it to you in degrees, you have to make that conversion, because that's what the formula is about. All right? Okay, let's do another one. Oh, looky here. Here's example 8. Let's do a quote-unquote real-world problem. We have Reno, Nevada is due north of LA. The latitude of Reno is 40 degrees north, and that of LA is 34 degrees north. The N and then 34 degrees in means north. Oh, okay. North of the equator. If the radius of the Earth is 6,400 kilometers, find the north-south distance between those two cities. Now, I like this picture, but I wish that wouldn't have put this in there, so I'm going to get rid of it here real quick. I know that due north here, LA, here, Reno is due north of LA, so this distance. From the equator, Reno is 40 degrees. From the equator, LA is 34 degrees. So the big question is what's the distance, the arc length here, because this Earth, is a circle, or is a sphere, honestly, but we're coming up here, and I want to know what this is. So if this is 34 and this is 40, then what is my angle measurement between those two? Yeah, just subtract it, right? And you get 6. That's your arc length, 6 degrees. So my formula is S is equal to R theta. But in this situation, my radius is 6,400. My angle is 6 degrees. Can I have it in degrees? No. So what do? Just multiply it by pi over 180. That's literally it, right? It's really no big deal. You've got this. So S is now equal to, if I go through and simplify and work all that out, you're going to come up with approximately 670 kilometers. And I'm putting this in terms of kilometers because we came up with our radius in terms of kilometers, so you want to keep that same unit measure. All right? What's the moral of this story? Plug it into the formula. What's the biggest issue associated with this formula? Theta has to be in radians. All right? Good. Okay, let's do some more. Okay, here's my next one. So that is arc length. The next thing that we're going to talk about is area of a sector. That's an E. Area of a sector. And a sector here, if I have my circle. Ooh, that's a lame-o circle. Let's try again. Not better, but a little bit. From my center, if I'm going out, my sector, oh, come here, you little stinker, is this piece, right? So my sector is like a piece of the pie. So that's what we're coming up with. The formula for area of a sector, area is equal to 1/2 radius squared theta. And again, theta is in radians. So I'm going to give you your formulas, but you are going to have to know what all these pieces are, and most importantly, you have to know how to do your angle measurement. All right, area of a sector, it's just that piece of the pie. So all these examples are just plugging into a formula, and I will give you these formulas. So here's example 9. Find the area of this field in this formula. Or in this picture. Find the area. Oh my gosh. Find the area, oh, for crying out loud. Find the area of the field. Oh, for goodness sakes. Okay. This field, miraculously enough, check out the shape of this field. It is in a sector. I know these are hokey, you guys. I 100% get that, right? I totally get that. So this is basically, these are just ways for us to use these formulas. These do show up. So let me just give you that right now. When we are not going to use a whole lot of these after this, but a lot of these show up in physics when you actually apply something. If you have this sector, something that you're looking at that is pie-shaped, and you need to know the area of this so that you can figure out what does it take to fill it in, or how much paint, or whatever the heck you're talking about, right? So there is some validity to this. Basically, typically whenever we have our geometry, it's just these polygons that we look at. This is just a way to say, hey, here's a bunch of different things we can do with circles. And trig has a lot to do with triangles and circles. Okay, so there's my spiel. But what do? We rock the socks off of this. My radius is 321, we see. This is my angle measurement, but theta, so this is my angle, but we have to make theta in terms of what? Radians, yo. So I now know that my area is equal to 1/2 radius squared theta. So area is equal to 1/2 321 squared times 15 pi over 180. Because I'm taking my degrees into my radians. And this is where we all get super excited about having a calculator. Plug it in. And we are going to, so this is giving me an approximation here. We have this in terms of meters right now, so we want to keep it as meters. But what do you know about the label? Anytime I'm talking about, anytime I'm talking about area, what do you know about that label? Square units, right? Square units. So this is going to be approximately 13,500 square meters. All right, you're literally just plugging all that into your formula or into your calculator and pulling that off. Now here is the kicker to this one. This 15 is a degree, so I'm just multiplying all of this out to pull that out. So you're good to go. Questions on that? Write them down, email me, or ask me whenever we get into our virtual sessions. All right? Okay. Now, we have looked at arc length.